Okay, now the 24th problem, okay, that is find the limit of the function when x is approaching 1, where the function is this, okay, that is x squared minus 1 when x is less than or equal to 1, and minus x squared minus 1 when x is greater than 1, okay. Now when we take the number line, see if this is a number line and we want to find the limit of the function when x is approaching 1, so let this be 1, this point be 1. Now x is approaching 1 from the right side and x is approaching 1 from the left side, okay. Now if the function is greater than 1, so right side will be the greater and left will be the lesser one, okay. So 1 is greater than 1, so greater than 1 will be this area, okay. It is, the function will be minus x square minus 1, okay, and equal and less than 1 will be this area, okay. So that function will be x square minus 1, okay. Now this is the function for the left hand side and this is the function for the right hand side. Now x is approaching 1 from both sides, okay. So now this distance, this length, we consider it as h, and this h shows us the position of x, okay. This distance, okay, this length gives us the position of x. When x is moving from here, the length will be here, h will be here, and when x is moving, the h also decreases, and when x moves and comes to 1, the h also decreases and becomes almost 0, okay. So this is the distance of h. Now as x is moving towards 1, h tends to 0. Now we can say h tends to 0, and here also as x is moving towards 1, h is tending to 0, okay. So now we can say that x is equal to x position will be 1 minus h, okay, and here position of x will be 1 plus h, okay, which is equal to x. Now the left hand limit LHL will be limit of the function as x is approaching 1 from the left side will be 1 minus, which is equal to limit f of x. Now instead of x we write 1 minus h, and h tends to 0, which is equal to limit. Now let's put the 1 minus h, let's replace x with 1 minus h, okay. So it becomes 1 minus h whole square minus 1, okay. H tends to 0. Now this is a minus b whole square. Let's expand it. So limit h tends to 0, 1 square plus h square minus 2h and minus 1, okay. Now putting the value of h in the function, we get 1 plus 0 square minus 2 0 into 0 minus 1. This becomes 1 plus 0 minus 2 0 0 minus 1. So 1 and 1 get cancelled, we have 0. So the left hand limit is 0. Now coming to the right hand limit, RHL, limit of the function as x is approaching 1 from the positive side, okay, from the right side, that is 1 plus, is equal to limit of function f when, now instead of x we replace it with 1 plus h, okay, and h tends to 0. Now which is equal to limit h tends to 0. Now in the function we replace x with 1 plus h, okay, here. So it becomes 1 plus h whole square, okay, and this is minus x square, okay, minus 1 plus h whole square minus 1. Now this is a plus b whole square. Let's expand it, okay. So equal to limit h tends to 0 minus 1 square plus h square plus 2h minus 1. Okay, now let's take minus inside. Minus 1 minus h square minus 2h and minus 1. Limit h tends to 0. Now let's put the value of h in the function. Minus 1 minus 0 square minus 2 to 0 minus 1. So minus 1 minus 0 minus 0 minus 1. So which is minus 2. Now RHL is equal to minus 2. Now you see here LHL is 0 and RHL is minus 2. So left hand limit not equal to right hand limit. Okay. So we can say that therefore limit of the function does not exist. Okay, that's it. When there is no limit, when limit does not exist, then there is no limit. Okay, that's it.